इंग्लिश से प्रॉब्लम नहीं, साउथ वाला सही है.
हाँ, stream visible. Hello.
Yeah.
अंडा लॉन्ज पे आजा.
Okay. So problem A tells us that we have submitted our problem at a time X. Okay. We have submitted our problem at a time X, and we have made YWAs. So if we have made YWAs and we have submitted at time X, what is our total penalty? Our total penalty will be X plus 10Y. Simple as that. So that's what you have to do. Your answer is X plus 10Y, and this is the answer. So that's A. Now coming to B. Problem B. Cool subsequences. What was this? Complement. Okay, this one. Okay, so in A but not available in B. Okay, so what do you want over here is you are given a few subsequences. So you are given an array B and you are given an array A. You have to choose such a subsequence such that you find. So basically what the question states that over here these are all different subsequences. You have to choose the subsequence, and 2 to 8 is a good subsequence because every because as you can see, all of the all of the averages of subsequences of this thing are present in B, right? And what is not present in B? Basically, wait, let me just read the question. I forgot completely. Okay. Okay, so I need to print a legal subsequence. Okay, I was thinking illegal. What is this? Okay. So we need to print a legal subsequence such that our answer will always exist in the array. Okay, sorry. Extremely sorry. There is no array B here. What is this? Okay. Subsequent reversal is subsequent formed by the elements we didn't consider. Okay. Oh, okay. Okay. So complements. Okay, so I'm given a subsequence A. I have to choose some sort of a subsequence in A such that I remove these elements and the remaining part forms my complement subsequence. So I have this as my complement subsequence and this as my original subsequence. Now the average of all the numbers in this subsequence should be present in my complement subsequence. So I need to find any one of these subsequences that exists. Okay. And it's not just average, but average of literally all. So one construction that you can make is, if you have an A here and you have an A over here, you can put this A in a subsequence and rest all in the complementary subsequence. Now this A is part of the complementary subsequence and the average will always be A by 1. So I have my answer. So anything, if it has a frequency of 2, my answer is yes. But let's assume it has a frequency of 1. Right. So I have a 1, I have a 2, I have a 3, I have a 4. Basically, the second test case over here, any cool subsequence such that all subsequences ka sum I have over here. So if I take so if every number in this whole array, right, is distinct, then how can I have a cool subsequence? Because now 2 comma 4 is a subsequence I selected. So I'll have a 2, I'll have a 4, and the other average will be 3. 3 is so there, but 2 and 4 won't be there because they occur just once in my array. So that is why we just cannot have if every element occurs exactly once. If all elements in the array are distinct, we cannot have an answer. Else we have an answer, which is just a single element. That's it. So if you have not understood, please tell. I was solving the fifth question, which is quite similar. So that is why I am a bit confused at this point. If you have any doubts, please tell. In B. Hello? No. Okay. Oh, wow. People have gone here. Magic. Wow. Okay. So now coming to problem C. What is the problem C? Problem C tells me that I have okay, let me again read. Okay, I have two arrays. I have an array A and I have an array B that is smaller. So what I can do is I can replace elements from array A with any cyclic shift of array B, and I need to make array B the lexicographically smallest thing, right? So how do you and I want to make array A lexicographically smallest. How do you achieve this? First things first, if I'm replacing it with array B and I want it lexicographically smallest, I will have to find the lexicographically smallest cyclic shift of array B. Correct? Once I have this lexicographically smallest cyclic shift, I can just keep on putting in my array B, meaning that I have an element, let's say A here, let's say some X here, and I have Y, Z, and C. So if let's say my X is greater than Y, I can just put in a Y, big deal, right? But I will also have to put Z and C along with it. And last three elements, let's say I am like not putting anything currently. Okay. Now, what I will do is I will just compare my. Now I'll come here. So since I have put a Z here, I'll compare my Y with this Z. But how can I know what value is there over here? You can keep track of the last place you applied this permutation, but sequence. So let's say you applied at position I, last application, and now you are at position I plus D, right? So what value will come here? Value D is going to come here. It's simple as that, because on the 0th position I have this, on the 1th position I have this. This is at I plus 1. So I plus 1 pe, I will get the 1th position over here. So I'll compare it with this only. I'll compare it with this only. And if it is not equal, if this kind of a condition is met, Z is greater than Y, then apply again here. So we keep on doing it until here. And then in the end, what I'm doing is I can just make two arrays. One is completely identical, and one is this. The other is where I have applied Y, Z, and C. So I just updated the last. This is the last index I can update. Now just compare both the arrays and print the lexicographically smaller one. That's it. Nothing else. And how do you now find the smallest lexicographical shift? This is done using an algorithm called as Booth's algorithm. You can search it up online, or on LC also you can find it. So basically this is the lexicographically smallest cyclic shift. You can get it using Booth's algorithm. And once you get this cyclic shift, I am just seeing where previously I applied it. If I haven't applied it, or if it is if I have applied it and the position where I have applied this is within the range. So basically if it's was of 3 range, I applied it here, but my current pointer is at this point, so it does not have effect over here, basically this thing. So I will change A, and if A is greater than this and I am applying only till n minus m, not these last three positions, not the length of B. So we just change it and we have our previous apply. And this is how we can form A. Now after A, I make a copy array, and in the copy, I just put in my last B, and we just check which array is smaller, and we print that using like which array is lexicographically smaller. Understood? Hello.
बूथ एल्गोरिथम का मेरे को समझा नहीं, मतलब कैसे आया?
Booth's algorithm nahi exist. It exists as in you have an array. It is a standard well-known algorithm like Codechef algorithm. You can just black box it.
ओके ठीक है.
Like if
पता
you
नहीं था तो इसलिए मतलब आई वाज ट्राइंग कि मतलब उसका मतलब कि मिनिमम इंडेक्स निकाल के उसका प्रीवियस बार-बार चेक करना.
so you can get your answer in big O of n using this. So
ओह अच्छा.
that's easy, basically. Now, coming to problem D. So what does problem D state? Problem D states that I have an array of seats, and what I want is I want the, and I have another permutation P something 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 something. I have another permutation. Now I want to check if I can get the exact arrangement of the permutation as and when the people come in. Okay. So what does this mean? So it's and as and when the people come. I'm assuming you all have read the question. If you all have not read, so it's something like person one comes in, he will sit in one place. Now person two will come in, he will sit on a place that is farthest from one. So he will sit here or here and here, and so something like that. So if person one sits here, then two will sit here. If person one sat here, two will sit here, something like this. Then the second goal is that wherever a person sits, they want to maximize the person coming after them ka sitting position. Like they want them to sit farthest away. So basically, if I put one over here, two will have to go here, and the distance between them is just two. Whereas if I put one over here, two will still have to go here, but the distance between them is 4. So this is a better position for one as compared to two, as compared to this position. So it is by default obvious that one can be here or here, one of the two positions, nothing else, and rest all can follow. Now let's just take one small other edge case. Let's assume you have 1, 2, 3, 4, 5 positions. So this is that position, this position is at distance 3, and now you have another position that is at distance 3. You can go anywhere, right? Because person sitting here won't affect person sitting here, or person sitting here won't affect person sitting here. But now if I remove one position, and let's assume there are 4 positions. So this is 2, this is 2, this is 1, this is 1, this is 1, and this is at position 2. So person sitting here, I will still have a 2 here. If I have a 2 here, I will still have one, either one of the 2 here. So it doesn't matter wherever the person sits, because I just want to help the next person. So now how do we check if this permutation is possible? So our first check is one has to be either at the first position or the last position. Okay, that has been checked. But now I have put a 1, then I put a 2, then comes a 3. So where all, in which all positions can I put a 3? So what I can do is I can just perform a BFS on this array completely. So if I have put position of 1 over here, I'll have a 0, 1, 2, 3, 4, and 5. These are the distances that I will have to traverse through. Now, by default, I will have to put 2 over here. I'll again perform a BFS, but now this BFS won't be on the whole array. Why is that so? Because I want the nearest distance. So this is 0. I'm going on 1. I'm going on 2. This distance will be 3, but here the nearest node is 1. So the distance will be 2. And anything ahead will still be the same. So this thing does not, so anything ahead is going to still be the same. So this will be 1 only and this will be 0 only. Correct? So I need not traverse this part of the array. So every number I add, I am just reducing the amount of spaces I'm moving. So first I have n, then I'm moving n by 2 spaces. Then I'm roughly moving n by 3 spaces, n by 3 or n by 4. I don't know. But it is being factored by half because I just won't move 1 part of the array is the thing. So this whole thing amounts to n log n. N log n. That's it. And since it is n log n, we can literally just traverse through this. But now the second thing is we also need to check that when I'm inserting an element, let's say I'm inserting a 5, it is being inserted at the farthest possible position. So what I can do is I can maintain a set of all of these things. So I can insert in the set, and the set will store distance, comma, index, right? So for every index and distance I have it, and the final distance, so I just want the biggest distance to be equal to 5's distance, wherever I will be placing 5. Let's say the biggest distance is 2 and I want to place 5 here. Okay, so the distance at this block is also 2. Okay, perfect. Sorry, I want to place 5 here, let's assume. So distance at this block is also 2. Okay, it is 2, so I can use it basically. So that's all you have to do. So the biggest distance has to be the same. Let me just go through the code once. So I have an integer, I'm taking the permutation and I'm calculating everyone's position. If position 1 is not last and it is also not 1, so answer is straight up no. Now I have an vector called nearest occupied and my set s, and everything in nearest occupied is put as int max, currently the distance. And if I want to do a BFS, I'll just, let's say from this position I am inserting a node, everything I go till here and everything I go until here will be changed. So yeah, so that's what I'm doing. So if any node has a distance that is greater than my current distance, so I'll just remove that and I'll add that distance, I'll change it and I'll insert it in the set. Same thing going opposite side, basically two things. And I'm just adding 1 over here. Then from 2 we just keep on adding. So 2 has to be at the last position, so farthest distance, since in set everything is sorted. This is the max distance. So if my maximum distance that is there is not equal to this thing, I see out no. And if it is, then we just insert that in our array and we again perform a BFS. It's a simple function call, and the answer is yes if it has never come out to be a no. So this was D. Any doubts? Hello. No. Okay, great. So people, nice to meet you all. Also, we are organizing event called Code Uncode on Unstop. Please do register. Search for Unstop Code Uncode. Please do register over here. Oh, we have skyrocketed in impressions. I hope you all have registered, and that's about it. Thank you very much. Have